So one of the advantages of using parametrics to represent the coordinates and the curve is we can come up with a general equation for specific features. So the first one I'm just going to look at is a chord of a parabola. So there's our wonderful parabola. A chord, same as in a circle, it's the same thing. It's just any line that joins 2 points on the circumference, or in this case, on the parabola. So there's 1 point. I'll call it P, and creatively I'll give it the parameter little p. So it becomes 2ap, ap squared. And then the other one will be Q, and I'll give that the parameter little q. So it'll become 2aq, aq squared. And so a chord joins those two things up. And so the question simply is, what is the equation of the chord? Well, it's the same as we've been doing all the time with coordinate geometry. I want to find the equation of a line. I need two things. Those two things are point and a gradient. Well, we've got 2 points. All I need to do is work out a gradient. So, slope formula. Now, this is where all our work we did earlier in the year with algebraic fractions and that comes in handy, because we're going to get all these algebraic fractions. There's going to be cancelling. ap squared minus aq squared. I got a common factor of a. It's going to leave me with difference of 2 squares. On the bottom, I've got a common factor of 2a. So let's factorise all that. The p minus q cancels. The a cancels. So the slope of any chord will always be p plus q on 2. So if you know the parameters of the 2 points, basically the slope is the average of the parameters. If you look at it, add them together, divide by 2. All right, let's put that in the point slope formula. Y minus, I've chosen to use the point P, ap squared, p plus q on 2x minus 2ap. Multiply by 2. Now when I expand out on the right hand side, I didn't bother writing px and qx, because we would have had to group that together anyway, because we want an equation of a line, so we'd want something x, something y, and so on. So there was no point expanding out the p plus q if I was only going to group it together later on anyway. As opposed to the constant, I did expand that out because there's another constant term on the other side, the minus 2ap squared. And in fact, you'll notice it's on both sides. We'll cancel the minus 2ap squared. And so there is an equation of the chord, written a little bit strangely, because normally we've drummed it into you that when you write the equation of a line, you should either write it as y equals mx plus b, or in general form. And now we contradict ourselves by saying, oh look, here's the equation of a line. We've got x and y on one side and the constant on the other. Okay, so p plus qx minus 2y is 2apq. Now, you would normally have to either derive this in the test, or they might give it to you to use. Sometimes they'll give it to you. Depends how many marks are in the question. They might not want you wasting time deriving it, and they'll say, oh, using this equation, or something like that. Or, alternatively, if the question was only worth 1 mark, then they're probably not going to worry about whether you derive it. In that case, it's probably okay to quote it and just put in. So you can let the marks be a guide. But you need to know how to derive it just in case. That's what they want you to end up doing. Okay. Now, a focal chord is a very special chord. It's one that passes through a focus. Hence the name, focal chord. I guess it's similar to, in a circle, the diameter. That would be a chord that goes through the centre of the circle. So, focal chord. So there it is. Now, when you have a focal chord question, usually there's other things they want you to do. If it also goes through the focus, so I know that PQ goes through the line 0A. And what you usually have to do in some question involving focal chord, somewhere in the question, there'll probably be a part where you have to come up with a relationship between P and Q. So what do? Well, I'd go and find the slope, like we just did. Remember, it ended up being the average of the parameters. So I'd go and do that. But then I'd go and find the slope of PS, or the slope of QS. It doesn't really matter. And so what do I got? AP squared minus A on 2AP minus 0. And that one tidies up to be P squared minus 1 on 2P. But PS and PQ, it's the same line. So therefore, those two slopes are equal. And so then we can say, oh, well, p squared minus 1 on 2p is equal to p plus q on 2. Playing around with that, we come up with this relationship. Oh, look at that. The parameters multiply together to give -1. So PQ is -1. That's how I'd do it if I hadn't already derived the equation of the chord. There's a quicker way if I already have the equation of the chord. So the equation of the chord that we just worked out before, p plus qx minus 2y is 2apq. Now if I already know that, and if it's a focal chord, then I know if I substitute in 0a, I must get a correct statement because it lies on the line. So subbing in 0a, and we get straight away pq equals -1. A lot quicker. So it depends what we've already done in the question. If I've already derived the equation, then I'll do it the second way because that comes out quite quickly. Otherwise, if I have to go from scratch, then I'd probably do it the first way. I could prove that relationship. And later on, we'll see some more questions where we actually then go and use that relationship to prove different things. Okay. 9e. So, I'm feeling very generous. Look at that. 1, 2, 3, 4, 5, 6 questions to do. I wonder what was wrong with question 6. 1, 2, 3, 4, 5, 7. Don't touch question 6, okay? What you got?